Introduction. Planet Earth has always been in a state of dynamic change, from the violent processes that formed it to the gradual evolution of life and the more recent human influence. Predicting the future of our planet involves a combination of scientific understanding, environmental trends, and speculative extrapolation. Here, we envision 20 milestones that could mark the journey of Earth from the present day to its eventual perish, illustrating not only the physical changes but also the potential societal and technological developments that humanity might experience along the way. Global warming intensifies, 2030 to 2050. The current trajectory of global warming is expected to continue, driven by greenhouse gas emissions. By mid-century, average global temperatures could rise by 1.5 to 2 degrees Celsius above pre-industrial levels. This warming will lead to more extreme weather events, such as heat waves, droughts, and powerful storms. Sea levels will rise due to the melting of polar ice caps and glaciers, leading to the displacement of millions of people living in coastal areas. The consequences will be felt in agriculture, with food production becoming more challenging due to changing climate patterns. Technological Renaissance, 2050 to 2100. Despite the challenges posed by climate change, this period could see significant advancements in technology. Renewable energy sources, such as solar and wind power, may become the primary means of energy production, reducing dependence on fossil fuels. Breakthroughs in artificial intelligence, biotechnology, and nanotechnology could revolutionize various sectors, including medicine, agriculture, and manufacturing. Human life expectancy might increase due to advancements in healthcare, and space exploration could become more common, with potential settlements on Mars or the Moon. Global cooperation on environmental issues, 2100 to 2150. Faced with the growing threats of climate change, nations around the world might come together to form robust international agreements aimed at mitigating environmental damage. Efforts to reduce carbon emissions, protect biodiversity, and promote sustainable development will intensify. New policies and technologies will emerge to manage resources more efficiently, reduce waste, and recycle materials. The shift towards a circular economy, where waste is minimized and materials are reused, will become more prominent. Climate refugees and migration, 2150 to 2200. As certain regions become uninhabitable due to extreme weather conditions and rising sea levels, there will be significant migration of people seeking more stable environments. This era will see a large number of climate refugees moving from affected areas to more temperate zones. Countries will need to adapt to this influx by developing new infrastructure, housing, and support systems. International policies and cooperation will be essential in managing this mass migration and ensuring equitable distribution of resources. Decline of biodiversity, 2200 to 2250. Biodiversity will continue to suffer due to habitat destruction, pollution, and climate change. Many species will become extinct, and ecosystems will be disrupted. Conservation efforts will intensify, focusing on protecting remaining habitats and restoring damaged ecosystems. Biotechnology might play a role in de-extincting some species or creating genetically modified organisms to fill ecological niches. However, the overall loss of biodiversity will have lasting impacts on ecosystem services and the stability of natural environments. Transition to post-human society, 2250 to 2300. Advancements in artificial intelligence and biotechnology could lead to the emergence of a post-human society, where humans augment their bodies and minds with technology. Cybernetic enhancements, genetic modifications, and brain-computer interfaces will become common. Society will grapple with ethical and philosophical questions about identity, consciousness, and what it means to be human. This period will see the rise of a new class of beings who possess capabilities far beyond those of unenhanced humans. Terraforming and extraterrestrial colonies, 2300 to 2350. With advancements in space travel and technology, humanity will begin serious efforts to terraform other planets and establish permanent colonies in space. Mars and other celestial bodies within our solar system will be the primary targets for these efforts. The challenges of creating habitable environments on other planets will drive innovation in fields such as environmental engineering, sustainable living, and closed-loop ecosystems. These colonies will serve as a backup for human civilization in case of catastrophic events on Earth. Peak resource consumption, 2350 to 2400. The demand for resources will reach its peak as the global population stabilizes and consumption patterns plateau. Resource management will become a critical issue, with a focus on sustainable extraction, recycling, and efficient use of materials. Innovations in resource recovery, such as mining asteroids for minerals, will supplement Earth's dwindling supplies. Societies will need to balance consumption with the carrying capacity of the planet to avoid severe shortages and environmental degradation. Artificial superintelligence, 2400 to 2450. The development of artificial superintelligence, ASI, will represent a major milestone. ASI will possess intelligence far surpassing the combined intellect of all humans. This technology could solve many of humanity's most pressing problems, from curing diseases to addressing climate change. However, it will also pose significant risks if not properly controlled and aligned with human values. The governance and ethical use of ASI will be a central concern, with potential implications for every aspect of society. Global governance and unity, 2450 to 2500. As global challenges become more interconnected, humanity will move towards a more unified form of governance. International institutions will evolve to handle global issues such as climate change, resource management, and technological regulation. This period could see the establishment of a world government or a federation of regions, promoting peace, cooperation, and equitable distribution of resources. The concept of national sovereignty will be redefined to accommodate this new era of global unity. Quantum computing revolution, 2500 to 2550. Quantum computing will reach its full potential, revolutionizing fields such as cryptography, material science, and artificial intelligence. The ability to perform complex calculations at unprecedented speeds will unlock new scientific discoveries and technological advancements. Quantum networks will provide ultra-secure communication channels, and quantum simulations will offer insights into phenomena that were previously beyond our understanding. This revolution will drive further innovation and reshape industries across the globe. Advanced climate engineering, 2550 to 2600. With the climate continuing to change, humanity will deploy advanced climate engineering techniques to mitigate and adapt to its effects. These techniques will include large-scale carbon capture and sequestration, solar radiation management, and weather modification. While these interventions will help stabilize the climate, they will also come with risks and ethical considerations. The balance between technological intervention and natural processes will be a key focus, with an emphasis on minimizing unintended consequences. Interstellar exploration, 2600 to 2700. Building on earlier achievements in space exploration, humanity will venture beyond our solar system to explore and potentially colonize exoplanets. Advances in propulsion technology, such as the development of faster-than-light travel or wormhole navigation, will make interstellar travel feasible. These missions will seek to identify habitable planets and establish new human settlements. The search for extraterrestrial life will intensify, driven by the desire to understand our place in the universe. Cultural and biological divergence, 2700 to 2800. As humans spread across different planets and adapt to diverse environments, both cultural and biological divergence will occur. Societies on different planets will develop unique customs, languages, and social structures. Genetic and technological adaptations to local conditions will lead to distinct physical and cognitive characteristics. This divergence will raise questions about identity, unity, and the definition of humanity, as the species becomes increasingly varied and complex. Sustainable galactic civilization, 2800 to 3000. Humanity will transition into a sustainable galactic civilization, with interconnected colonies across multiple star systems. Advanced technologies will enable efficient resource management, renewable energy production, and closed-loop ecosystems. Communication networks will span light years, maintaining connections between distant colonies. The principles of sustainability and harmony with the environment will guide the development of this civilization, ensuring its long-term viability. Encounter with extraterrestrial intelligence, 3000 to 3500. The long-anticipated encounter with extraterrestrial intelligence will finally occur. This contact will profoundly impact human civilization, offering new knowledge, technologies, and perspectives. The nature of this interaction, whether cooperative or adversarial, will shape the future of both species. Humanity will need to navigate the complexities of communication, cultural exchange, and potential conflicts with these advanced beings. The encounter will redefine our understanding of life and our place in the cosmos. Universal consciousness and integration, 3500 to 4000. Advancements in neuroscience and artificial intelligence will enable the merging of human consciousness with digital networks, creating a universal consciousness. This integration will allow individuals to share thoughts, memories, and experiences instantaneously. The collective intelligence of humanity will expand, fostering unprecedented collaboration and creativity. This era will bring about new forms of art, science, and philosophy, as the boundaries between individuals blur and a new collective identity emerges. Energy mastery and cosmic engineering, 4000 to 4500. Humanity will achieve mastery over energy, harnessing the power of stars and other cosmic phenomena. This era will see the construction of megastructures, such as Dyson spheres, to capture and utilize vast amounts of energy. Cosmic engineering projects will include the manipulation of planetary orbits, the creation of artificial habitats in space, and the stabilization of celestial bodies. These endeavors will demonstrate humanity's ability to shape its environment on a cosmic scale. Preparation for solar systems end, 4500 to 5000. As the Sun evolves into a red giant, preparations for the end of the solar system will intensify. Humanity will undertake efforts to relocate to other star systems or create self-sustaining habitats capable of withstanding the changes. This period will involve significant scientific and engineering challenges, as well as the emotional and cultural impact of leaving the solar system that has been home for millennia. The preservation of Earth's legacy and history will be a central concern. Earth's final days, 5,000+ billion years. As the Sun reaches the end of its life cycle and expands into a red giant, Earth will become uninhabitable. The planet will experience extreme heating, leading to the evaporation of oceans and the destruction of the atmosphere. In the final stages, Earth may be engulfed by the Sun or reduced to a barren, lifeless rock. However, by this time, humanity or its descendants will have moved beyond the solar system, carrying with them the knowledge, culture, and legacy of their origins on Earth. Conclusion. The journey of Earth from the present day to its eventual perish is a complex tapestry woven from scientific predictions, technological advancements, and speculative possibilities. Each milestone represents a significant turning point in the planet's history, shaped by natural processes and human actions. While the future holds many challenges, it also offers opportunities for growth, discovery, and the continuation of life beyond our home planet. This vision of Earth's future underscores the importance of stewardship, innovation, and resilience as we navigate the path ahead.